Sathyabama Institute of Science and Technology.
Hi, young and active learners. Wish you all a very great day from Dr. A. Viji Amutha, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. Very glad to meet you again in this video lecture on explanation of binary search algorithm. So in this video lecture, we are going to learn what is that binary search algorithm, what is the working process, pros and cons, and its time complexity. Let's get into the video. This binary search algorithm is an efficient searching algorithm which is used to find a specific value in a sorted array. And it works by repeatedly dividing the search interval in half. And it follows the divide and conquer approach. Let's go to the working process. Here, the very first step is finding the middle element of the sorted array. The target element is compared to the middle element. If the middle element is equal to the target element, complete the searching process, that is, the search process is completed. If the target is lesser than the middle element, then confine your search in the left half of the sorted array. Otherwise, confine your searching process in the right half of the array. This process is repeated until the target element is found or the search interval becomes empty. Now let's have a glance of the algorithm. Let us start from the main function. So in the main function, we see that we have declared three variables: array, n, which is the number of elements in the sorted array, and x, which is the target element, which is to be found out in the sorted array. And get the number of elements of the sorted array, which is n, using a for loop. Get the array elements one by one, and then get the target element, which is to be found out in the sorted array, which is the x, which is equal to x. Then call the function binary search. So now let's go to the function. So in the binary search function, we have the parameters array, x, low and high. So array is the input array and x is the target element, and low and high are the lower and higher indices. So now we have the while loop, while low less than or equal to high. So that is the terminating condition. While low less than or equal to high, then it enters the loop. The core of the algorithm starts here. First find the middle element, mid equal to low plus high divided by 2. That's the formula used for finding the middle element. Then compare the middle element with the target element x. If both are equal, then return the position mid. Otherwise, compare if middle element is lesser than the target element x. If so, then adjust the lower index, low equal to mid plus 1. Otherwise, adjust the higher index, high equal to mid minus 1. So now we exit the while loop. So if the element is not found, or if the search interval becomes empty, then it comes out of the loop and it returns the value minus 1. Okay, now the position of the target element is stored in the variable result. So if result equal to minus 1, that indicates that the element is not found in the sorted array. Otherwise, it will print that the element is found at the position. Okay, that is the result. So thereby we conclude this algorithm. Now let us see the explanation of binary search algorithm with a small example. So now look at the example. We have 6 numbers here in this array: 12, 17, 20, 25, 28 and 40. Just note that the numbers are in sorted order. And each number has some index, and 0 is the lower index here and 5 is the higher index. So let's take the target element as 17 here. So x equal to 17. Now let's start the procedure. First find the middle element, mid equal to low plus high by 2. So here the low is 0 and the high is 5. So 0 plus 5 divided by 2 gives 2.5, but we take only the integer value here. So let's write the value as 2. Okay. So the middle element is 20. And now we find that the middle element is greater than the target element. Okay, that is 20 is greater than 17. So now we have to adjust the higher index as high equal to mid minus 1. So mid is 2, so 2 minus 1 is 1. So now our higher index is 1. So now we confine our searching process only in the left half. So we take only the first two elements as our searching process. Okay, so 0 and 1. So here the elements corresponding to these indices are 12 and 17. So again we repeat the process once again. So find the middle element, mid equal to 0 plus 1 by 2. So 1 by 2 equal to 0.5, which is equal to 0, since we take only the integer part. Now the middle element is 12. So here we find that the middle element is lesser than the target element 17. So now we have to adjust the lower index. So low equal to mid plus 1. So that is equal to 0 plus 1, which is equal to 1. So adjust the lower index now. So in the next step we see that the lower index is equal to 1 and the higher index is also equal to 1. So both are pointing to the element 17. Again repeat the same process. Find the middle element. Now the middle element is low plus high by 2, which is equal to 1 plus 1 by 2, which is equivalent to 1. So the middle element is 17 here. So here the middle element is equal to the target element, which is equal to 17. Now the position 1 is returned as the answer here. So students, now I am giving you an assignment. Now take an element in the right half of the sorted array and do the procedure just like this and find out the answer. Enjoy it. Okay, now the advantage is binary search is significantly faster than linear search, especially for large data sets. And the drawback is it can apply only on a sorted set. So the time complexity of the binary search algorithm is big O of log n, where n is the number of elements in the array. So with this, I conclude the algorithm. So hi learners, hope you have a great experience in learning this binary search algorithm. Let's enjoy our continuous learning process. We'll meet you in the next video lecture. Thank you once again.